Awesome. Okay. Good afternoon, good evening, everyone. Welcome to the HamSCIence Telecon. Today is January 30th, 2100 UTC. And we've got, I think, an interesting program tonight, which I'll talk about in a minute. But before we jump into that, before I forget something, I wanted to share my screen real quickly. I'll show you a little bit of software. So hopefully my screen is showing a bunch of call signs and whatnot.
Yes.
So we often talk about spots and how important and valuable amateur radio spot data is to the HamSci research and to others. So I thought I'd show a quick glimpse of the screen from my logging software when I'm operating a contest. This is some software called Skookum Logger, and this is what the spots look like when they are live. The call sign is the skimmer is picking up on the radio, its frequency, an approximate signal report, and the source, the station who's reporting it. In this particular case, I was looking for stations both in Ohio and in Pennsylvania. I mean, it doesn't help me to know what people on the West Coast can hear because I'm too far away, right? So you'll see here that even there's Nathaniel skimmer was running on this particular morning. But the reason I brought this one up is you never know who's going to show up in the skimmer. There's Jim. I had no idea, Jim, that you and I were both members of CW Ops, and you were in a CWT early in December.
Yeah, perfect.
So I had to do a screen chat.
Yeah, very nice signal as well. I'm pleased with that.
You did. You sure did. And the skimmer was about 5 miles away from me, but by the time I tuned down to you, you weren't there. So maybe you weren't calling CQ. Maybe you were doing something else. So.
All right. Yeah, that's cool. Thank you.
Yep. It's always fun to run into your HamSci pals on the radio. It really is. It's a lot of fun.
Hey, Gary, after a long absence,
Steve.
this is Penn State checking back in. So I wanted to just get with you guys for the beginning of the semester, and I'll turn it over to you to run the program.
Oh, fantastic, Steve. Good to have you along. And maybe it's my imagination, but it seems to me more and more university activity is showing up later and later. I think Nathaniel's talking about working with, I think he said SUNY, which would be the City University of New York. That's a new one on me. And of course, Penn State's with Jim Breakall there, of course, has been a longtime supporter and advisor to HamSci too. So good news. Good to see you, Steve. I think we'll get ready to turn the meeting over to our speaker. Bill Lyles is here tonight. Bill's an accomplished engineer. He's got a rather storied career, which is a nice way of saying he's probably a little bit older than me, but not much. But he's currently a co-editor of QEX magazine, and he always has his fingers in a lot of interesting pies. So today we're going to talk a little bit about NOAA weather satellites, I believe. So Bill, if you want to take it away, we'll turn it over to you.
Okay, and if you can tell me how I can share.
There's usually the green arrow at the bottom of the screen, and
Yep.
it says share. Yep.
Okay.
We're seeing it.
And you still see it?
Yep. Open weather.
Okay. Okay. So welcome all. And I'm going to talk about a group known as Open Weather. Basically, the crowdsourcing weather image collection from NOAA satellites. The satellites are 15, 18, and 19. The other numbers that are missing, like 16, 17, those satellites died quite a few years ago. So this work is really done mainly by Dr. Sasha and Sophia. And they're amazing people. They are basically artists, and their medium for some of this stuff is the electromagnetic spectrum. So doing artwork with stuff that can't be seen is a really interesting way of doing art instead of putting paint on a canvas. And so Sasha is on the faculty of Royal Holloway in London, and Dreyer lives in Vienna, Austria currently. They're both hams, of course. And that antenna that you see her holding, that's a circularly polarized, right-hand circularly polarized 2-element Yagi Yuta antenna that's that's cut for the frequencies we're going to talk about, but these are the people that are really behind it. I just do help them. Okay, so this is the type of images that are collected. Is there some way of shrinking so I don't see? Yeah, okay. So these, normal weather sort of images, these will happen to be taken from my house. So you can see the ocean, the end of the Atlantic Ocean and the eastern seaboard up in Canada and Virginia and stuff like that. And so that's what we're going to be talking about. Here's the satellites. Look at the dates that those satellites were launched. The fact that they're still working is amazing. They were only supposed to last for 2 years. And so you can see like NOAA 15 has kind of gone past the 2 years. You can see the frequencies that they're at. And because of the age, this transmission is all analog. They take 8 bits, convert it to an AM signal. They modulate that AM signal around a 2400 hertz carrier, and then they take that and FM modulate it to those frequencies that you see there. So in order to receive it, you basically receive it as FM, demod it, and now you have the AM, which you now have to demod. The bandwidth is 34 kilohertz, which makes it hard for some amateur equipment that's used to narrowband FM to receive it. But lots of other SDRs receive it just fine. Really powerful signals, in my opinion. 5 watts directly from space to you, with not much in between. And I'll give you a little bit more detail on this later. Here's what the signal kind of broken up is. It just scans across the Earth. As it scans, it transmits it down. So it's not trying to save it up to put to some ground station. As it scans across, it sends it down. It takes a half a second to scan one line of 2 images. And basically those images are either one of 2 infrared channels or 1 visual channel. Usually during daytime, they do 1 infrared and 1 visual. At nighttime, it's usually the 2 infrareds. And you also see that there's a thing called sync A and sync B. Sync A is a frequency of 1040 hertz. Sync B is, people recognize that number, 832 hertz. And I'm going to play you what this sounds like after the demodulations have been done. And so if I can find my mouse, which... Okay,
give me a few seconds to review your account.
Okay, so you can hear those sync signals really well. And then the kind of in between them, which is the image. So what does it take to do this? Let me close that.
Are we supposed to hear something,
it's even a
Bill?
laptop. And so what a lot of people use is
Bill.
RTL SDR dongles. And there's an antenna kit with a dongle that you can get for about $40 off of Amazon. And basically, you can just make a simple dipole with that, and that's good enough. You don't need that 2-element circularly polarized Yagi-Yuta. However, that's a really good antenna, and I'm going to talk more about using that later. Okay. So there's making one just out of some aluminum rods, and just set up that angle and the length. It works fine. I've done that. And there's Sasha doing it with the tape measure antenna. And folks, if you have 2-meter antennas that you use for satellites or for fox hunts, they work just fine. Yes, 144 and 137 megahertz aren't the same frequency, but they're close enough that you get the gain from the antenna still. Okay. So what software do you need? Okay. SDR software, and you folks probably have your favorite, SDR Shop, SDR Play, et cetera, et cetera, et cetera. Cubic is kind of nice because it runs on multiple platforms. To create the image, I'm going to talk about one that we developed that's called open-weather.community/decode. It's the one I recommend. SatUp is another good one. The one that's famous for decoding these images is WX2Image. It was great in its day. It hasn't been maintained in years. It goes off to URLs that aren't there anymore. So you got to kind of patch around this code that the source is lost for. I shouldn't say lost, it was never revealed. If you go to YouTube to see how to do this, lots of people use that. SatDump and the open weather one is just much easier. Here's what it looks like on the decode page for that website. Now, that looks pretty plain. There's a reason for that. So one of the things is, how do we get communities to use this? One of the ways that we found is you want to get schools involved. And in the US, a lot of schools won't let students go to websites like newspapers or other sources that have dynamic content on their page, because they have no idea what's going to come up and whether it's going to be appropriate for the student to see it or not. So this page comes up looking exactly the same every single time. The teachers that we've shown this to have liked that because they said, okay, we know we can go there. We don't have to worry about something strange happening. All the decode of the image is done on the person's laptop. We never upload to a server the actual WAV file that's been collected by the SDR software. So we don't have that issue. One teacher actually asked if we could locate where that student is by looking at those images and figuring out where they had to be to get those images. And when I explained that if I wanted to know that, I could actually get the student's IP address and know it pretty well. And they said, oh, right, okay. But we don't do that either. So that's what the basic thing looks like. After you decode it, there's the images. And if you notice on the upper left, there's a button that says upload to the year of the weather. It's only if you click that button that image will be uploaded to our servers, where we're trying to collect images around the world during this top for a year. If you don't click that, nothing is collected. So the reason I like this software is because it works, it's simple, and as long as people have a relatively modern browser, it works. For example, Linux, Windows 10, Windows 11, Raspberry Pi running either of its operating systems are out there, Mac, different versions of Mac OS. As long as it can run that browser, this software will work. It's all in JavaScript. I recommend that nobody else develop single processing code in JavaScript. It was not designed to do that. It doesn't really understand complex numbers well, but we got it all working. And over on the left-hand side, you see that we have different ways of decoding. So for example, I said that you have to do an AM demodulation. There's 3 different ways of doing it. Then it goes down and says, find the sinks. It can look for those sync signals or not. And you can see the sync signals. If you look at the leftmost part of that image, you see those lines, vertical black and white lines. And then you go over halfway and you see those lines, but with different spacing. Those are actually the sync signals. So we can say, don't go to sync, see what happens, do it. You can put in histogram equalization on it. You can see both images or just one or the other. And because these satellites are on polar orbit, they could be going north to south or south to north. So we can flip it 180 degrees to line up with the Earth. The reason for those sort of options, though, is because this is used not only with youth, but also with students at different universities, and we want those folks to experiment and see what happens with different demod techniques in that. One, workshops. This is the main way that the wood has gotten around. We have lots of pictures I could have put up for workshops. I've just put up these two because I want you to see that people are actually getting engaged with it. If you look over on the leftmost image, you see somebody holding a little tripod with what looks like an old-fashioned rabbit ear. That's the antenna you get from RTL-SDR.com, and you don't have to hold it. You can just put it down on the tripod and let the satellite do its thing. But you also notice that we have people holding antennas. One of the things that we have found is people get bored if you just set up an antenna and let the satellite fly over and they see something on a computer screen. People actually like tracking the satellite by holding an antenna. And especially when we do this with youth. We get lots of antennas out there, so lots of people, youth can there and scan the sky, moving it, and you can see on the display for an SDR receiver, on the waterfall display, you can see how the frequencies shift due to Doppler. And so they actually say, oh, okay, I'm not getting the right frequency. I got to move it over a little bit. And then they see it lining up again more. Turns out the software takes care of the Doppler shift. So they don't have to do that. But that gets them involved and it's a topic of discussion. We can get them doing stuff with that. Okay. We also have an automatic ground station. So you can set it up so you don't have to do anything. This is so people can install this and just keep collecting, like on with the grape. It just sits there and collects these images and keeps uploading them to our server. And there's Sasha busy soldering the things together. It's nice to see a faculty person soldering. Okay. Now, the question is, where are our collection sites? Well, here's the map of the US. Guess what? We have big gaps, as you can see, like that whole midsection, we don't have anybody there. So anybody who wants to do this, we would love to have collections sites over there. Okay. Europe and England, we pretty much got covered. One reason is it was easy for Sophie to get around doing this. But you know, we're missing Spain and some other places. So anybody has any idea where we can put an automatic ground station or have people do this like it? Africa, we actually have some in Africa doing it. These data points are all on the archive that people can download the CVS file and do all this mapping. Okay. So how can somebody contribute to this? If you go to our website and go to the rest of that link, you will see complete instructions how to do everything, how to set it all up. If you remember earlier, I said that the bandwidth of the signal is 34 kilohertz. Well, if you read those instructions, it says, set the bandwidth of your receiver to 40 kilohertz. Then that's to take care of the Doppler. So all those fine points are explained on that web page. It's easy to follow. One of the things we did with this software is if your FM demodulator is sampling at 48 kilohertz, 44.1 kilohertz, 20K kilohertz, I don't care. We take whatever sample weight you can give us, as long as it's high enough to get the data through, and we filter it and resample it based upon whatever sample weight you give us. A lot of the other programs out there that handle satellite stuff require specific sample weights. And that program I suggested not to use, the sample weight it wants is 11.025 kilohertz. And if you think about that, you realize that that's not an even number. So on a scan line, there's not an even number. And if you're slightly off, weird things happen. I don't know why they decided on that number, but because of the promise of that particular software, lots of other software for handling these images and demodulating them and coding them also use 11.025 kilohertz exchange number. We will handle that also, but you don't have to do that. Okay. And I've already showed you how to put it up into the archive. So that was a very quick run through of kind of what we're doing. So
That was fantastic, Bill. One
put a link in
question
the
a
chat.
couple of people asked
Okay.
is it possible, we didn't hear the audio signal, and sometimes in sharing, playing audio is a challenge. I get, I grant you that.
That's the homepage of all that stuff. Now, stop sharing. Okay, I'm back. So questions?
So I have
Yes, Mary Lou.
I have a question.
I mean, I can't hear you,
So-
so let me.
I hear Mary Lou.
Yeah, I hear
Okay,
her too.
Okay,
Let's try this again. Can you hear me now?
yes,
Okay. So you have these people with these antennas and the laptops, and sometimes they click the button and put the stuff in an archive. What is then done with the images in the archive? Who's using them and what do they have plans for?
okay, so there's a group of designers, artists up in Glasgow called Rectangle, who then go and produce. I would have picked a different shape, but that's who produce different sort of artistic images of the Earth doing this. For example, a while back there was a climate change conference in Scotland, and they took these images and basically projected them as if they were on a 3D globe that rotated, so that the people attending the conference could see what this weather was like around the world. Of course, we were missing large gaps. So that, and when people submit stuff, not only do they submit the images, they're also allowed to submit comments about it. What did you find about this experience? What does weather mean to you? What does climate mean to you? And then ask other sorts of questions that they can contribute to.
Do you get a lot of comments or very few?
I think almost everybody comments. Sometimes it's just like, I'm doing this standing out in the rain, you know, which is good, right? That means they were interested enough to do it. But sometimes they said, here's people walking by were asking me like, what am I doing out here holding this thing up in the sky? And so that the whole length of time from horizon to horizon is like about 10 minutes. And so they can usually say, wait a minute, let me finish this pass, and then I'll tell you about this. So it's if it gets dialogues with other people in the park or wherever they are outdoors, that's all for the good. Yeah, NOAA does not collect this stuff.
What could a school group then do with any of their or other people's images? Could they track a big storm that's going across
Yes,
Scotland or something like that? Do people do that and make it as a science project? What have you heard?
yes, but the trouble is that we have big spots of discontinuity. So each pixel of those images is about 4 kilometers square. And so if I'm picking it up over the west coast of the US, and then I have a gap between the people on the East Coast start picking it up. And so you can pick up the same storm. There's just a gap.
Okay, could people in Los Angeles or in California see the smoke from those wildfires?
Oh, yeah.
That'd be interesting.
Bill, I had a question. First of all, I wanted to comment, really nice talk. You did a nice job. Does your software, your custom software, does that talk directly to the RTL, or is there an intermediate step where I like to have SDR sharp and then interfaces with your software?
Okay.
I didn't pick up that detail.
Okay. And because I left it out, so thanks for reminding me. So I'm assuming that when you have the antenna and an SDR on the laptop, you're in fact receiving that signal onto the laptop with an FM demodulator. So you now have a wave file that's audio on the laptop. And then that website I showed you demodulates and decodes that wave file.
Okay.
Okay. Now, when you use an SDR, so some SDR software you select FM, some you select WFM for wideband FM,
Mhm.
and then you should set the bandwidth between like 40 and 45 kilohertz to take care of the Doppler. Because if you just do normal wideband FM, that's designed for FM commercial stations, hundreds of kilohertz wide, you're going to get lots of noise in there.
Yeah.
And I want to minimize that noise.
So we'll want to adjust our sample rates accordingly then.
Yeah. So what most software defaults to, if you do an FM demod, it assumes that you want a high quality audio file. So they would go to 44.1 kilohertz or 48K.
Mhm.
That's just the default on a lot of them. And that's perfectly fine with me. It's a larger file than I need. I mean, you can give me, 20 kilohertz and I'll do fine. But if you gave me 44.1 kilohertz or 48 kilohertz, I'll just filter it and downsample it myself.
Okay.
And that
Thank
makes
you
it
very
easier.
much. Mhm.
And what we tried to do was make it easier. There's some software out there that says, okay, get this with the SDR. Now you have this file at 44.1 kilohertz. Now bring up Audacity and through Audacity, filter it down. And then we'll get this new wave file. And then you take that wave file into this other software. And I'm going like, okay, if I can skip that step of going to Audacity, that's where people don't really understand downsampling and that and what it takes to do that type of filtering, it's much better. So that's all been eliminated.
Well, thank you very much for your answer. Appreciate it. Good talk.
Yeah, but thanks for asking. I forgot to say that.
Bill, fantastic to see satellite pictures on the thing. It's just incredible how it's changed. I go back quite a long way in meteorology, and then just to put some colour on it for people, in the late 60s, when I joined the UK Met Service, we didn't have satellites at all that we could use as forecasters, as operational meteorologists. So from the late 60s through to about the early 70s, we relied on surface ship observations over the Atlantic to see what the weather was doing. And we've moved all the way through that to where you are now, that you can get satellite pictures aplenty on a mobile phone in your hand. Just incredible. But the point I wanted to add to this is something that I think Mary Lou touched upon about the use in schools. I do a lot of outreach stuff over here to schools of various age groups while I was at work particularly. But the point of a satellite picture for geography, for physics, I mean, to see the physics of what's happening in the landscape, how the temperature changes, why the seas are warmer and colder at different times of the year, and all of those things that comes into how the whole planet works. It's a real gift. So to see any mechanism that puts that stuff in the hands of local users and school users, where you've got time to develop thoughts rather than just press a button on a mobile phone, I think it's brilliant, Bill.
Well, the thing that we have found to build off of that is the students are all used to seeing satellite images before we ever show up at school.
Yeah.
On their phone, on a computer, right? They already know what a satellite image looks like. They've seen it on TV, weather reports, or other places. But they don't really understand how that image got to them.
No.
And so having them stand out there and watch the signal come down and start and see nothing on the waterfall of the SDR software and start to see the signal start to rise up above the noise. And that they're like, what? Right? And of course we play with demodulating as it's going on from FM so they can actually hear something. And it's just something that they find really strange, but it starts a conversation, which is what I want to start.
Yeah,
Right?
yeah. No, and the other thing is that I noticed that you can place a great emphasis on the infrared part of the spectrum for
Oh,
this.
yes.
And there's so much information there that people don't see in their few seconds on a television weather map, weather satellite picture. You don't get a chance to look at all that beauty and exciting detail of the physics in the atmosphere if you don't have time to ponder an infrared picture. So,
Right.
so I just think it's a real gift to education, several different branches of education.
Yeah.
So
So one of
Bill, I would ask you, could you possibly put up again the picture, the slide that had the two pictures, visual and infrared, and then have Jim talk about it?
okay, so I have to share my screen again, right?
Yes, yes.
Okay. Something, hang on, folks.
Incidentally, are any of you familiar with a group called RIG, R-I-G, the Remote Imaging Group over here in the UK? They did a lot of homebrew reception of satellite data back in the 90s, the 80s and the 90s.
I somehow I've lost the ability to share.
Oh,
I see Jim, but that's all I see.
have you got your little green button pressed with the arrow going up?
Now I have it.
Should be somewhere at the bottom of the screen. Oh, there we go.
Okay. So
That one on the left will do, probably.
I have to make it bigger. That one,
Yeah.
yeah. Oh, that's lovely. So which one is which?
Well, actually, there was one that I noticed because a lot of this is over the ocean, and it's a more generic, uniform sort of area to look at. Whereas the one
This
over
one?
the UK, that's the one. Yeah. So the infrared one on the right-hand side. I mean, you quickly see, for example, a big difference off the coast of Spain and Portugal and Northwest Africa, where the visible satellite picture has picked up a layer of stratocumulus cloud, probably, where you've got warm air overlying a very cold upwelling current in the ocean there. But the heating effect of the land, of the sunshine over Spain, very effectively pushes that back to the coast. So you don't get...
Could you show me where Spain is?
Oh, down in the
Okay.
bottom right.
Yeah.
So you
Look
can
at the
see
rightmost image and go to the bottom right, and you see Spain right above the top of Africa.
Can
Yeah,
you see
there's
the
the Straits of Gibraltar in there, right?
Okay.
Yeah.
Can you folks see my mouse?
Yeah, put your mouse there, but there we go. There's Spain.
Oh, there's Spain. Okay.
Yeah. Now, if you look just to the left of Spain, Mary Lou, you'll see on the visible picture to the left-hand side, you've got that broad band of cloud that stretches all the way down that coast. This one, to the right, Bill, the one right of there, that one. Yeah, if you come down there, past the coast of Spain and to northwest Africa, all that is stratocumulus cloud, I would think, overlying a cold upwelling sea current, and you get that as a semi-permanent thing. This is probably I can't see what time of the year or time. It looks like it's a middle of the day sort of picture. Is it summertime?
I don't remember where I got this from. I probably so.
Okay. Well, other things that spring out, for example,
Oh,
is
wait a minute. We got the date.
have we?
If you look at the mouse,
2021, 07/20, July 20th.
July
So
20.
Jim's
Oh, well,
right.
there we go. Yeah. So that
Jim's
would
right.
figure. Good. Thank you. Well, the other thing to look at then, draw your attention to a very narrow band of clouds, southern France, just on the northern side of the Pyrenees, just on that top right-hand cut. The one above that one there. Can you see that little bright dot in the middle? There we go. The little bright dot halfway along it.
yeah,
That looks like it's a bit of convection triggered by the Pyrenees, the uplift over the mountains of the Pyrenees.
Wow.
And then you get slightly cooler air that's come down across France because the infrared signature is not as warm as Spain. And then when you look at the UK, you'll see you're just getting a couple of very isolated dots over the Midlands and East Anglia, two isolated tiny little pinpricks, which are the first signs of isolated convective cloud forming, because for some reason locally you've triggered a cumulonimbus cloud to develop there, and as opposed to anywhere else nearby. And then you've got all the other cloud and the debris over northern Britain. But there's all sorts of oh, and then if you look over southern Scandinavia, just above the UK to the right, you can see a couple of very strong isolated cumulonimbus cloud cells showing up there as well, those bright echoes. And the combination of having visible and infrared, because if you look at the visible, you wouldn't know about those bright echoes over Scandinavia very clearly. They just appear as part of a cloud mass. So the combination of those two spectrums of observation really crucial to gleaning a lot about the weather. So this comma-shaped cloud in the south, in the Atlantic, southwest of Britain, shows that that's not driven by temperature, because if so, why isn't it happening everywhere else either side of it? That is a band of cloud that's triggered and driven by some dynamics in the atmosphere, like an upper trough pattern, which causes extra uplift. There's just 101. It's like looking at a map, you know, a topographical map of anywhere. The longer you look at it, the more you see. Anyway, sorry to bang on about that for a second.
no, but I want to go something else off of this. Is like, okay, this is a very old system, analog, basically 8 bits, black and white. The NOAA satellites that they have today, and in fact, these satellites have much better, higher resolution sensors on them than this old format. The trouble is they're either up a geo, which means you have to have a much better antenna because of the path loss, or they're much higher in frequency for the LEO satellites. And because they're high in frequency, you have a larger Doppler shift. So you really do have to track it as it makes the path. Both of those makes it hard for youth to do it.
Yeah.
Because these things are down at 137 megahertz,
Yeah.
that Doppler's not enough to really cause a problem that I can easily take out into single processing. And if they don't want to track it, they don't have to, and they'll still get a decent image. So NOAA, once these things shut down, it's using up resources. They won't put up any more satellites like this.
No.
These particular satellites are now being actually managed by a company that NOAA gave a contract to, because NOAA doesn't want to deal with it anymore. And so every time I meet somebody from NOAA, I said, please keep these things alive because of the education and experience that we can give youth by seeing this stuff that we can't do with your higher grade sensors.
Yeah, absolutely. I mean, just one last final point. Can you imagine if you look at the detail of the cloud over the Atlantic on the left-hand picture? So the left-hand half of that left-hand picture, look at the complexity of cloud there, and just ask yourself, how would you represent correctly what that looked like if you just relied on a few randomly distributed ships, surface ships, sending back weather.
Oh, yeah.
It's just phenomenal, the transformation that this technology has made to weather forecasting.
So I have a question, Jim. In your outreach to schools and whatnot, would it be possible to ask children in a school to do these pictures on one day and then print them out on a piece of paper and then sit in front of the television and look at the evening news when the weatherman is saying, and so we see here and there and whatnot, and have them mark on their paper what the weatherman has picked out as being an interesting thing to discuss, and then try to figure out why the weatherman didn't pick something else to discuss as well.
That's a very valid point. One of the things, having done that job as well in my past, one of the things that the meteorologist doesn't have any say in, really, usually, is the length of time they get to do the broadcast.
Well, right, they have 3 minutes to do it, so they have to pick and choose.
Oh, for a satellite component in it, you might have 15 seconds, perhaps 20. So one of the obstacles that we have with doing what we would call a good scientific job with them is that you can only pick one big key feature that's going to control what the weather is for the viewer. And most of the viewers won't even be scientifically minded. So they just see it as a big white blob and somebody waving an arm in front of it. But what I miss is the ability, and that'll be your next exercise, Bill, in coding, is having the ability to use one of these graphics drawing packages to draw the frontal structures on these satellite pictures, because that then gives you a whole new layer of explanation about what the pattern means. Otherwise, it's just a satellite picture. But if you can relate these arcs of cloud to being fronts, or even old fronts that are no longer active, like that bit of cloud we saw over the Pyrenees, that's almost certainly the leftover of an old weather front that's no longer active. But you should never ignore those things, because it contains enough middle level moisture for that to generate that isolated thunderstorm over the Pyrenees, which wouldn't have happened had there not been the weather front there to add the moisture. All these little things, they all add up into the mix.
How old is old? Just a few hours previous, or
no, a few days.
Ago?
A few days, Mary Lou. So
Days, okay.
the life cycle of a low, from when it develops on a waving front over the Atlantic, say over your side of the Atlantic, the life cycle to take it from there to a mature low, which then draws a front south across the UK into Europe, might be 5, 6, 7 days. The most active, that they have a life cycle like humans, and the difficult bit with lows and forecasting is their teenage years, because they are so mischievous. They have the ability to change the upper air pattern and the dynamics, the thermodynamics, the structure of the flows so quickly that the low can change it's always changing its direction, but can change its direction and its rate of deepening very, very quickly in those truculent teenage years. And nearly all the forecasting own goals that happen in the modern world of meteorology are to do with that period of a low's development, when the changes are very rapid. And that, sad to say, Bill, is where these lovely geostationary satellite pictures earn their keep. Because if you have one of those sat over you, looking at your part of the world, then you don't just see an image, but you see a time sequence, and you see the developmental components of whether the systems are getting bigger or decaying, and so on.
Do you often see bits over mountains?
You do quite often see either old front in Europe, I can speak of, you see fronts moving south across northern Europe and sitting as a layer of cloud on the northern foothills of the Alps, or southern Germany. You go to southern Germany, there's often a lot of cloudy, dull, damp days in the summer, when if you went over the other side of the Alps to the Po Valley, it'd be wonderful sunshine in northern Italy. And the only thing that's done that for them is the fact that the Alps are there and stops that cloud. And we see quite often on convective day when you're just developing cumulus clouds, a line of cumulus either over the Pyrenees, over the Alps, over the Pennines. Uplift over mountains is a very powerful way of getting clouds to form.
Well, then I think it might be interesting if you had a class of, I don't know, 12-year-olds, to give them a map like this, but have it the terrain, and particularly here's where the Pyrenees are, here's where the Alps are, here's where the Pennines are. Let's look for them tomorrow, and then take a picture like this, and for several days or whenever you get it, and say, has anybody seen the mountain effect yet?
Yeah, no, absolutely.
You know, and we could do a lot of science with these things if you supplied some of the information for them beforehand.
Yeah,
Yeah.
absolutely. Yeah, you got to prompt them or preempt it a bit to give them a clue what to look, because it will be different things apply in different seasons as well. You know, you wouldn't see some of these things going on in a winter set.
So, Bill, one of the real questions I wanted to ask you is how do you get citizen scientists? How do you get people involved? How could we help in the United States filling in the great middle there? What is your technique to get people involved and to get schools involved in that sort of thing?
So it's primarily been through those workshops, and those workshops are done through contacting schools and saying, hey, we can put on these workshops. Would it be good to have one in your area? So the people who show up at the workshops aren't just associated with the school, but we get somebody local that can take care of the local logistics. But I have not actually taught any of those workshops. There's only been one workshop that I know of in the United States, and that was a workshop to teach people how to conduct workshops. So that the Sasha and Soph don't have to travel to the United States, but people in the United States could go around. And because they're artists, the folks that they usually contact are art departments, because that's the people they know.
Sure. What does the art look like? You should have pictures of some of the art. Or does it just look like this?
No, it doesn't look like this. So yeah, I keep thinking, along with Christina Collins, that someday at HamSCI workshop, we should take over a gallery at whatever university is hosting us and put up.
NJIT.
Yeah, well,
We
yeah,
know what it is. It's called NJIT.
yeah, but we don't have enough time to do that, because all the people I know who do this type of art is outside the United States. And when Christina and I looked at what it costs to ship artwork from Europe to the United States, getting a grant to do that, we just haven't got it all together yet.
How about for this one coming up at NJIT, you ask artists if they could take a photograph of their art, and you print a whole bunch of 8x10 pictures and post them on the wall with the artist's name and a little discussion about what they were trying to do in this particular picture. So it's not the art, it's a picture of the art, but with the important part of what they were trying to send a message about when they did this art. I think that
I can ask
really
that
cool.
question. I can ask that question. I think artists prefer people to see the actual artwork, but I can ask that question. So I was going to say something else about schools. The youngest folks in schools that I know of is to do this was folks in 3rd grade here in the US. And to them, you know, they've never seen anything like this before in their life.
Yeah, I think elementary school would be really cool.
Yeah, and that's what we discovered, that we need to give them antennas that they can actually track the satellite with, because they're doing something. When it was just an antenna that was stationary and they just look at a waterfall, it didn't mean much to them. But when they could actually track it and see how they adjusted for Doppler and signal strength on the waterfall, that got them more excited.
That would be really cool. I would like to see that too. So for the HamSci workshop, if you could come in March, could you bring a setup like this and show us in the parking lot one day? That would be really cool.
Sure,
Could I hold the antenna for a while?
sure. And by the way, if you folks have like an aero antenna for 2 meters and 70 centimeters for satellites, those work just fine.
Gareth, you have to talk now.
I've done it with a Oscar satellite.
Yeah,
Mary Lou, maybe we should get together.
Yeah, Bob.
yeah, no, I can bring the stuff. I had all the stuff at AGU to do this. So I could show people, yeah, they saw pictures on the poster, but they didn't see the physical thing.
Did you
And
get to do it?
no, because I was indoor. And yes, 5 watts is a lot, but in that building is so off noisy. Not a good signal.
Do you think you could do it from camp? Is it in Newark, downtown Newark?
Oh, yeah.
Are you allowed to go outside, Gareth?
As long as it's not too cold. I mean, there's a rooftop kind of deck at the center where we're gonna have the meeting. So it might even be, you could just probably walk out and kind of do things outside, right? So that might be.
But could it have all the attendees on that rooftop at the same time?
Not the rooftop, but maybe. I'd be kind of. I don't think it's good for that. Maybe groups at a time because it's kind of fairly narrow.
How about down on the ground level?
You could do it on the ground level in the green, yeah.
Yeah, the green is nice.
But I could bring multiple dongles and you know, I'll only bring one laptop, I assume, but other people will have laptops that can have the software on it to.
Yeah.
That's what students are for.
Ah,
I think that would be great fun. So I think you should reserve, Gareth, some time for this demo. Yeah, that would be cool.
okay, well, Gareth, I'll have to pull down the orbit elements because there's fixed times when that satellite's going to be overhead that I don't control.
How many satellites are there?
Said there were
There's
3.
3.
Okay, I'm sorry, I hardly ever make it here because this is nap time. But I got in late and I didn't see the beginning and
Okay, so there's 3 satellites. NOAA 15, 18, and 19. And 15 sometimes gets flaky and then it gets back to being normal again. So I do collect from 15, but occasionally it just something goes wrong on board, and that's understandable given its age.
But that would be really fun. Also, another thing that I don't know if you could do between you and Jim Bacon is to have Jim look through the archive and pick out 3 different days that are really indicative of this phenomenon or that phenomenon or the other one, and explain to us what a meteorologist sees when all the rest of us just see sort of swirly white bits. Would you do that, Jim?
Yeah, I'm happy to do that.
So
Yeah.
I can send you the link, Jim, and also when you download the archive as a CVS file, it gives long lat of where those things were collected.
Okay.
And dates.
Yep.
So-
Perfect.
So
Yeah.
that may help you filter without having to look at all the images.
Yeah, I'll get 3 or 4 examples of different elements. Yeah.
So the other thing, if most of them are collected during daytime, but based upon what Jim said, maybe what we should do if we're going to do something at NJIT is bring a file where we collect both IR bands at night. One's at 10.8 and the other one is at 3.7.
Well, in the
Does it right,
trade,
Franz?
Yeah,
yeah,
micrometers.
Yeah, in the trade, the nighttime infrared ones tend to the two are used to detect fog, because if you can imagine for an infrared picture, the ground temperature will be very similar to a fog down at the surface. They will not be contrasting enough. So using the two wavelengths does give you an ability to sometimes pick up fog that you wouldn't see at night, which can be very important from a public or an aviation forecasting sense. But for the example for children and for the wider public or attendees of the conference, I would think of a full-on headbanging daytime infrared
Okay.
and visible pair together would be best.
Okay. That's easy to do.
Yeah, good, good.
Fantastic. Any further questions for Bill or Jim?
Yeah, Bill, I can't remember if you actually mentioned this or not, but are the GOES satellites still sending down APT, or has that been
They're
discontinued?
not sending APT.
Okay.
So
Yeah, because there was a
that's the-
time it's a higher frequency, but they were sending the same format.
Yeah. As far as I know, they're no longer sending APT because they got better sensors on them and APT, those satellites basically do store and forward so
Right.
that the ground stations can collect all that data.
Now, another source of weather is on HF. Those I think are still broadcasting.
There's still HF weather broadcasts. And
Right.
by the way, there's another whole set of satellites that are not NOAA. Russia has a set of satellites that are still doing APT also.
Oh, that's true too. Right.
Mhm.
And the same frequency band. If you look in the radio regulations, that band around 137 is reserved for this use. And everybody has heard, oh, as long as we're low power, we can transmit and it's okay. Part 15, the FCC rules in the US. That's not true for that band around 137. No other transmissions are allowed.
On the clouds.
Well, because they want to make sure that people can receive this when they wrote those regulations. So
That's
I'll
one
tell you
of
what we do when we do the workshops. Have you seen these little devices where you can transmit from like a phone or a CD player that over the FM to the FM in your car radio?
Sure.
Okay, that audio file that I played for you, I put it into one of those devices and I send it over to a local FM frequency that's legal to do. People set up their equipment, demod, and see that image. And then when the satellite comes over, all they have to do is shift over to the frequency I care about, but I already know that they have the equipment set up. Because otherwise, you run this workshop and you don't know if all the students, I shouldn't say students, attendees have the equipment set up properly, and they have one shot. Because after that satellite's passed, it's another day before the next one comes by, maybe. So there's a way of testing this before the satellite actually comes and not transmitting on 137. Because that's what I wanted to do until I found out it's not allowed.
In
I'm like
in reality, when these things did their polar orbits, you'd get perhaps two passes in the morning going one way, and then two passes in the
Right.
second half of the day going the other way. And it would often be that Britain might be on one side of one pass and on the the near side of the next pass. So you tended to get a little glue stick and stick them together to look for the changes. But you have to remember then they're an hour and 20 minutes apart, whatever the orbital
Yeah,
period is.
and when we collect the data for these things, we know what satellite it was collected at, what time it was collected. So
Mhm.
and so therefore we can figure out what the geographics are of that so we can paste them together.
Yeah, cool.
And
Yeah,
that's what we do for some of the odd projects. They actually paste the things together that can be pasted together.
I think I saw somebody knit a weather pattern, a satellite picture on a either a big blanket or a big jersey. Because back in the early days in this country on television of showing satellite pictures for the first time, you had to get a red felt tip and draw a crude outline of Britain on, because you just present a satellite picture, you've got no idea what you're looking at. And you get this line going on there, and then you ended up pointing to them with a knitting needle. So you had this knitting needle sitting on a chair beside the satellite picture stand, and you'd have this shaky finger pointing a knitting needle everywhere. But somebody thought it'd be a great idea to make a knitting design either for a jersey or a blanket. I can't remember what it was. It could have been a shawl, but I do remember that in the past, and we had to send this satellite picture off to somebody who's doing that.
The program SatDump, when it decodes these images, you can turn on an option so it actually draws the country outlines.
Oh, right. Okay,
Okay.
cool. Yeah.
And we have not put that in yet. We don't know if we're going to or not. We also don't know whether we want to false color these things or not. Because what is actually sent is gray code, black and white. So putting in reds and greens and yellow, because I know where the oceans are, right? So I could say, okay, I'm going to make the oceans this color. I'm going to make land this color. I could do that, but in some sense, I want them to actually experience what's actually being sent.
Yeah, I agree with you there, Bill, about that. And I would say my recommendation, having looked at both different versions, one on a TV graphic system and one on a raw piece of paper printed out, the best one that works with minimal effort is to get a proper outline, a line of the coastline, but not to change the colours of the sea or the land.
Okay. Good to know.
Oh,
So if
excellent.
any
Well,
of you
Bill,
folks want to do this yourself and you need more information, let me know. Go to that webpage. If you go to open-weather.community, you will find a webpage that talks about do-it-yourself ground station and tells you all the stuff to do it. I'll be glad to help anybody who wants to do this.
Okay.
Hey,
And
Bill.
I'll bring my stuff to New Jersey.
Hey, Bill, question. How big are the files that you want transmitted to you if we do our own station and send it? How many megabytes are they?
Oh, just a few. I don't
Okay.
remember.
Okay. They're not gigabyte files.
No.
All right. And I happen to live in Hill Country, Texas, and there's another ham here on N5 NRA also lives in Hill Country, Texas. We're in the same radio club, and we could perhaps fill in that empty spot that you have on the map.
Oh, that'd be great. And like I said, we have an automatic station that does it. It's just a Raspberry Pi with a dongle.
all right. Anything else for Bill? Well, thank you very much. That was now if you're talking with everyone's contributions too. It was nice to see a lot of people chip in with questions and answers and whatnot.
Yeah, and I have
I don't know how
action
many-
items to do.
There you go. Well, when we in a week or so, when YouTube videos end up, I'll post that on the Google group with a couple of links, the
Okay.
open weather links, and a few others too. So,
Thank you all.
all right, good. Is there anything else for tonight? Otherwise, we'll hope. I'm thinking next week we may have a speaker on sporadic E, on 6 meter sporadic E, but I'm not 100% sure on that. So,
Well, where's
see what
Jim?
happens.
I did mine last year. I haven't got any new data yet.
So, all right, everyone, if there's nothing else, we'll call it a week. And thanks everyone for attending. We had over 35 people today. It was a
Yeah.
great crowd, and I hope everyone took a lot away from it. I know I sure did. We all experience terrestrial weather, day in and day out. And I'm hoping someday our space weather will have similar visualizations. We'll get the artists involved, whoever it takes, but we can see some of those structures in the ionosphere that we all talk about and look for. That's down the road, I hope. So,
Okay.
all right, everyone.
Take
Bye.
care,
Have a
everybody.
great
Take
week.
care.
Bye-bye.
Bye.
Take care, everybody.
Be in touch.
Great, outstanding presentation. Thank you.
Thank you.
Bye-bye.
Well done, Bill. Thank you.
Thank
Thank
you,
you.
Bill. Thank you, Bill.
Thank you.